Hi there guys, hope you're doing well. This is your friend and tutor Manas. So let's see what this problem has in store. Here we go.
Two cylinders A and B rest in a horizontal channel as shown in the figure. The cylinder A has a weight of 1000 Newton and radius 9 centimeter. Cylinder B has a weight of 400 Newtons and radius of 5 centimeter. The channel is 18 centimeter wide at the bottom with one side vertical. The other side is inclined at an angle of 60 degrees with the horizontal. Find the reactions at points L, N and P. Alright. So let us try to understand this entire arrangement. So we have this larger cylinder over here, 9 centimeter radii, self weight of 1000 Newton, and this smaller cylinder on top of it, okay, 400 Newton weight and 5 centimeter radii. Now these two cylinders are having some point of contacts. Now this cylinder is having a point of contact at L, and hence L is going to offer a reaction normal to this surface, that is RL. Secondly, this larger cylinder is also having a point of contact at N with the ground surface, and obviously the normal reaction is going to be in this direction. And normal reactions are basically directed towards the center. You can see this. Rn also is directed towards the center and RL also is directed towards the center. Now to move ahead, this larger cylinder is in contact with this smaller cylinder at point Q. Hence, this smaller cylinder is going to offer a reaction in the downward direction, which is directed towards this center of this larger one. Similarly, when you speak of this smaller cylinder, it has 2 points of contacts. One is over here, that is at point P, and you can say that the reaction offered at point P is going to be equal to Rp. Let me write that Rp, subscript P. Alright, and when you speak of this point, now this point is actually Q, and at Q you can see that there is a RQ in the upward direction directed towards the center. Okay, so the reaction at point of contact Q due to this larger cylinder onto this smaller cylinder B is going to be this RQ, okay, directed towards this smaller cylinder's center. Alright, so that was all about the arrangement. And let me tell you, we are going to solve this problem with the help of Lami's theorem. When you speak of Lami's theorem, we have to work with forces and the angles between them. And hence, it is our responsibility right now to work out all different sorts of angles in this particular figure. For that to happen, I'll do a little construction. Please watch this carefully. This is what I'm going to do. Okay. Now, here, initially to start off, I'm going to be calculating this angle. Let us say that this angle is represented by theta. Okay. Now, if you watch carefully, this has no name. Let me write it R. Let us say, and this is, let us say S, and this over here is represented by say U. Okay. And this over here, let us say is T. Now, if you were to calculate the angle theta, we know how much this hypotenuse is. This hypotenuse is how much? This is 9 from here to here, and from here to here it's 5. So 9 plus 5 is 14. But in order to calculate this angle, we need one more side. Okay. So what basically we're going to be doing is we're going to be calculating sine theta. Okay, sine theta here. You see, RU over RS. RU over RS. Okay. Opposite, that is perpendicular upon hypotenuse, RU over RS. What is RU? RU can be written as NT. So I'm going to write NT over here. NT. Alright. Now in place of NT, what can I write? This is MO minus MN minus TO will give you the value of NT. Something like this. Exactly. Now let us see what else can be worked out. You can see this MO, we know what the value of MO is. MO is equal to 18. We know what the value of TO is. TO, please watch carefully in the above side. We have this over here. This is how much? This is 5 centimeter radius of this smaller cylinder. Okay. So in place of MO, we're going to write 18. In place of TO, we're going to write 5. And in place of RS, we know what the value of RS is. Okay. Where is RS? This is 14, obviously. So here it is. And as soon as we place the value of MN, we're going to get the value of theta eventually. But we have to go through a lot of stuff, a lot of geometry and trigonometry both to get to the value of Mn. This is really crazy stuff. Okay guys, I want all of you to pay attention. Now we have to calculate the value of Mn. Mn seems to be a part of this triangle RMN. And if we were to calculate the value of Mn, so we need this angle over here. How can this angle be calculated? That is the issue. We know what this side is. This side is equal to 9 centimeters. And if we can somehow get the value of this angle over here, okay, if we can work out this angle, with the help of then trigonometry, we can get the value of Mn. It's very simple. But how can we get the value of this angle? And for this to happen, let me take you to the good old school days, something we learned in school in the form of congruence of triangles. Okay, so guys, right now what we're going to be doing is we'll be considering two triangles. This triangle, okay, this one, and this triangle over here. So let us just write that down. Consider triangle LRM and NRM. Let me show you once again. LRM and NRM. That these are the two triangles that I'm going to be considering, and I'll try to prove that these two triangles are congruent. So in order to prove that these two triangles are congruent, whole lot of criterions are there. There is SSS criterion, there is SAS criterion, there is AAS criterion. Whole lot of criterions are there. These two triangles are right angles. So I'm going to be using this criterion, not very popular, the RHS criterion. Now let us begin. Angle RLM is equal to angle RNM. Okay, why? Because 90 degree each. Secondly, hypotenuse. This is the hypotenuse which is common to both the triangles, and you can say that RM is equal to RM, common hypotenuse. Thirdly, one side, you can say that RL is equal to RN. Why? Because both of them are radii, and radii is equal to 9 centimeter. That's it. Now this is the RHS criteria, and by this criteria you can say that these two triangles, triangle LRM and triangle NRM, are congruent. And when two triangles are congruent, their corresponding angles and corresponding sides are equal. And by that logic, you can say that this angle over here is equal to this angle. All right. So let me write that angle LRM is equal to angle NRM. Now you have to watch this very carefully. I'm drawing a vertical line passing through this point L. Now this angle over here is how much? This is 60 degree, and hence this angle, let me extend this reaction RL in the backward direction. This angle is also going to work out as 60 degrees. Now guys, watch this carefully. This line is parallel to this line. Okay, and you can say that this RL acts as a transversal. If this angle is 60, this angle also has to be 60. This entire angle also has got to be 60. Okay, now this is half of 60, this is half of 60. In that sense, you can say that this angle shall be equal to 30 degrees. This angle also shall be equal to 30 degrees. Now we know what this angle is. We know this angle, we know this side, and now we're going to apply trigonometry to get to the value of Mn. And what we're going to do is we're going to apply tan 30 is equal to Mn over Rn, something like this. Okay, and we know the value of Rn is equal to 9. Just put the value, and then Mn is going to be equal to 9 times of tan 30, and you just need to do this calculation simply in a calculator, and you're going to get the value of Mn as 5.2 centimeters approximately. That's it. Now put the value of Mn is equal to 5.2 in this equation, and then you can proceed for calculation of theta. Something like this will happen, 5.2, and sin theta will eventually be equal to 0.557, and theta will be equal to sine inverse of 0.557, and theta finally works out as 33.86. Okay, so we have ultimately got the value of theta. So theta is equal to 33.86. Oh man, this is really crazy stuff. I mean, we are solving problem based on mechanics, and we are about to use Lami's theorem, but before that we have to go through geometry, we have to go through trigonometry to calculate this theta, because if you don't calculate theta, you cannot apply Lami's theorem. It's going to get very difficult for you. Okay, anyway, so we have done the majority of stuff, and we'll now make a free body of these two cylinders separately. We're going to separate them, and then we're going to go ahead and apply Lami's theorem to calculate the reactions at P, reaction at L, and reaction at N. So let's do that. Here it is, and let me make the center. Here also let me make the center. Yeah, pretty good. And let me make the coordinate axis also. Okay, I'm now going to be fixing the forces over to this side. Okay, from this main diagram onto this free body diagram, and let us kick off by drawing the free body of this smaller cylinder. Okay, and you can clearly see that this 400 Newton is acting in the downward direction, and this is gonna be 400 Newton. All right, what else? So you can see, guys, this angle is 33.86 and this angle is 30 degree. Okay, and now from the diagram it appears as if there is a straight line from S to M. Okay, but it's not. This line from R to M is at a different angle, that is 30 degree, and this line from S to R, which is orange colored line, is at a different angle with the vertical, that is 33.86 degrees. Now these two angles are very close, 30 degree and 33 degrees, a difference of only 3 degrees. That's why it appears as a straight line, but it's not. Let me tell you once again. Okay, now we're gonna go ahead and try to fix this PRP over here. It is in the left hand side direction, passing through this center S. So this is center S. Okay, so this is gonna be for RP. Let me write RP over here. Alright, what else? Now there is this RQ, this orange color dashed line you see. There is this RQ in this upward direction at an angle of 33.86 with this vertical line. Okay, so this orange colored line here corresponds to what? It corresponds to, let me try to draw this in a proper way. Okay, this is RQ from the larger cylinder onto this smaller cylinder. This is RQ, obviously making an angle of 33.86. 33.86. Okay, what else? So the free body of smaller cylinder is over. This is cylinder B, I guess. Yeah. Now this is cylinder A. Let me write over here A, and this is cylinder B. Okay, now let us try to work out the forces acting on this cylinder A. Okay, first of all, let me get rid of this RQ. Okay, now RQ is going to act in the downward direction when you speak of this larger cylinder. The smaller cylinder at point Q is going to exert a force of magnitude RQ in this direction, directed towards the center of this larger cylinder. So I'm going to be making over here, what is this? This is going to be RQ. Okay, now RQ, watch this carefully. RQ, this is the line of action of RQ. Watch this carefully. RQ is at an angle of 33.86 with the vertical. Okay, so this is the line of action of RQ, and the angle that it's going to make over here is going to be equal to 33.86. Okay, now the next stuff is this RL. Okay, so RL, watch this carefully. This reaction RL is making an angle of 60 degree with this vertical over here. So okay, so what we're going to do is I'm going to extend this. What is this? This is RL, and over here the angle subtended is going to be 60 degrees. That's pretty good. What's left? Okay, this Rn is left. It is in the upward direction. Let us take it as positive. This is in the downward direction. Let us take that as negative. And assuming Rn to be greater than 1000 Newton, the overall or the collective force for these two forces is going to be equal to Rn minus 1000 in the upward direction. So let me fit it over here. Rn minus 1000. Now we're going to pay tribute to Mr. Lami by applying his theorem and trying to solve the reactions and trying to compute the magnitude of reactions at point L, N and P. Okay. For cylinder, which cylinder is this? This smaller one, cylinder P. Yeah. Let us remember Mr. Lami. Okay. So we have this RQ. Okay. RQ over sine of the angle between the remaining two forces. So what are the remaining two forces? It's RP and it's 400 Newton. Obviously the angle between them is this one. How much? 90 degrees. So sine of 90 degrees, that's it, is equal to what? Again, we have this RP. Okay, let us work out RP. RP divided by, what is the angle between RQ and 400? This is the angle between the remaining two forces. If you consider this RP as the main force, this is the angle between the remaining two forces. So this angle is how much? This is 180 minus 33.86. So we shall write over here sine of 180 minus 33.86. Yeah, done. What's next? The force that is remaining is 400 Newtons. So let me write 400, and the remaining two forces are RP and RQ. So the angle between RP and RQ is this one, 90 plus 33.86. So sine of 90 plus 33.86. Okay, so what I'm going to do is RQ, let me write this again, RQ divided by sine 90 is obviously 1, and RP divided by sine of 180 minus 33.86. So I need to do this calculation. 180 minus 33.86 is how much? This is equal to 146.14, and sine of this angle shall work out as 0.557. So the overall value over here is 0.557 is equal to 400 divided by sine of 90 plus 33.86. So let us do this calculation. 90 plus 33.86 is equal to how much? This is equal to, let me see, 123.86, and sine of 123.86 shall work out as 0.83, and 400 divided by 0.83, this is going to work out as 481. So ultimately the figure over here works out as 481.69. okay, so RQ is equal to 481.69 multiplied by this one, and RP is equal to 481.69 multiplied by this 0.557. Now let us write the value of RQ. RQ works out as 481.69 newtons, and RP works out as 481.69 multiplied by 0.557, and this shall be equal to 268.30. okay, 268.30 newtons. Okay, fine. We'll now go ahead and try to pay tribute once again to Mr. Lami by applying his theorem for this cylinder A. All right, let's do that again. Let's write the Lami's equation for cylinder A. All right, so we have this force RL. Let me write RL over here, whole divided by sine of the angle between the remaining two forces. If RL is the main force, the remaining two forces are this guy, Rn minus 1000, and RQ. Okay, so the angle is from here to here. This angle, okay, is 180 minus 33.86. So sine of 180 minus 33.86. That's it. What is the next force that we're gonna take on? It's Rn minus 1000, Rn minus 1000 whole divided by, okay, what about the angle between the remaining two forces? So this is the angle, let me show you. That's the angle. Okay, if you consider Rn minus 1000 as the main force, the remaining two forces are RL and RQ, and the angle between them appears as if this is equal, this is 33.86, this much, and this much is how much? We don't know. So what I'm going to be doing is, please watch this carefully. This is slightly complicated, not that complicated in fact. Okay, this much angle. Okay, let me write this. This is 33.86, so it's going to be sine of 33.86 plus. Now we need to calculate this angle from this point to this point. Okay, so if you consider this as a straight line, okay, so then this is going to be 120 degrees. Why? Because 120 plus 60 is 180, and 180 is the angle for a straight line. All right, so 33.86 plus 120. Done. What else is left? RL has been worked out, Rn minus 1000 has been worked out. We'll now go ahead with RQ. I have to write it over here. There is no place absolutely. RQ divided by, okay, if RQ is the main force, all right, then the remaining two forces are this guy and this guy. Obviously the remaining two forces subtend an angle of 60 degrees. This is pretty easy, man. Sine of how much? 60. Damn easy. Okay, you need to solve this in order to get to the values of RL and Rn. How can that be done? Let me show you. RL over sine of 180 minus 33.86. So 180 minus 33.86 will give you how much? This is going to be equal to 146.14. Sine of 146.14 is going to be equal to 0.557, and it's going to be equal to Rn minus 1000 divided by sine of 33.86 plus 120. So 33.86 plus 120 is equal to, 153.86 and sine of 153.86 shall be equal to 0.44. So this is working out as 0.44. Let me write this 0.44, and this is equal to RQ. What is RQ? So we have already calculated the value of RQ. It worked out as 481.69. So what I'm going to do is I'm going to put the value of RQ over here, 481.69 divided by sine 60. So 481.69 divided by sine of 60, and this is working out as 556.20. Okay, or if you approximate it, 556 it's working out at 207. So I'll approximate it to two decimal places to 1. I'll write, yeah, that's it. You just need to solve this equation. Okay, RL will be equal to, let me write this, RL will be equal to 556.21 multiplied by this 0.557, and it's gonna work out as 309.8. Okay, so the final value of RL is equal to 309.8 newtons, and you have to do some calculation for getting to the value of Rn. Okay, let us do that. Now Rn minus 1000 is equal to 556 multiplied by this guy 0.44. So 556.21 multiplied by 0.44 is going to be equal to 244.73. 244.73, and when you add 1000 to this 244.73, you will ultimately get the value of Rn is equal to 1244.73 newtons. So that's the reaction at N. Okay, let me just try to make a box over here. Reaction at N worked out as 1244.7 newtons. Reaction at L over here worked out as 309.8 newtons, whereas the reaction at P, okay, worked out as 268.30 newtons. So there it is, guys, from geometry to trigonometry and finally to mechanics. That's it.
So guys, that was all from my side for today. If you like the content and presentation in this video, do give it a big thumbs up. And if you believe that this video tutorial has added value to your knowledge of mechanics, then do recommend this channel to your friends and classmates so that all of them can benefit. I'll see you again with a new problem. Until then, it's a wrap. This is Manas Patnaik signing off. Take care, have a great day, and keep learning.